Hey, hello everyone. My name is Rajyavardhan Mishra, and I will be the instructor for this session. Today we are going to see that how do we design a log search application. Yeah, so on the first slide, you can see the link to this slide, this time.cc/log search. I will also send it in the chat box. Okay, so this is my name, and this is my LinkedIn handle and my email ID. You can reach out to me if you have any questions later on. Okay, so the prerequisites for this session. I hope you all can hear me fine. Please type in the chat box. Okay, thank you. Okay, so the prerequisites are these four sessions, these scalable systems 1 and 2, how to do quick and approximate calculation, and which database to choose in system design interviews. And another point is that if you do not understand what is an inverted index, then this class should be done only after the above four classes. So I hope everyone has done the prerequisites. Maybe you can type in the chat box if you have not done the prerequisites. That will give me a good idea that where do we stand. Okay, so I assume maybe everyone has done at least some prerequisites. So let's move ahead. Okay, some ground rules. So please put your question in question box only. Please upvote similar questions instead of asking a new and redundant question. And I won't be checking the chat box frequently. I would be checking the question and answer box more frequently. During the session, we will pause and we will go through the questions asked in the question and answer box, sorted by the upvotes. We can also have raise hands at the end of the session when time permits. Please mute yourself. A very important point which I always say in my sessions, that please make use of IK mocks. They are your best friends. It was a game changer for me. And yeah, and then I do not claim to be a know-it-all person, so open to feedback and correction. So we all know that the services, they are the application services. They are always emitting logs. So let's say there is some order service. So it would be sending out logs like uh, order ID 123 confirmed, right, for user ID. This kind of log could be emitted from the order service. There could be some errors also being emitted. That error 403 access denied, right, for user ID 245. And we all know that the logs have levels, right? So they could be info, they could be warn, they could be error, they could be fatal. Right? Now, what happens is that whenever these logs are being emitted and they are being stored in some log application, and then software engineers, they are interested to go through these logs. Maybe they are trying to resolve some bug, or they are trying to understand that how their application is behaving. And to go through the logs, software engineers, they send some queries. So it could be that I'm sending some queries. Right. For example, give me all the logs for order service from date 12/12/2021 01 p.m. to 12/12/2021 0105 p.m. So for this just 5 minutes, and they can have more parameters also. Show me only those which have some kind of error. So there can be multiple dimensions to the search query here. Then another interesting thing could be, give me those log lines where user ID is something like 1238. Uh, 123 question mark 8. Right. So now it could be 123 0088 123 018. Right. So these kind of even regular expressions are also a fair game in these log search applications. Then there are other kind of expectations from a log search application. It could be that we are interested in live tailing. Right? So we know that this is a distributed system, because if it is just a single server, then we can go and log into that single server and go through all the logs locally, right? This kind of complex log search application is required when we have a distributed system, when these hundreds of application servers are running the service. Right now it's not feasible, it's not possible to grab something from all those hundreds of servers. So this is where the log search application comes into the picture. Now I could be interested in doing live tailing also. So I have launched my code in production, and now let's say I'm doing a A/B testing on user ID 1234. So I could be interested that there is some fancy UI where I can do the live tailing, and I can also say that user ID should be 1234. So now what this log search application should do is that it should be fetching the logs from all these servers, and then it should be showing only those logs which have 1234 as user ID in the line, in the log lines, and they should be this view should be dynamically updated because it's a live tailing, right? So this could be another complexity of the system. So size question is that when companies actually implement these log search applications on their own. So yes, your question is valid, and generally very large companies have their own solutions. So by large companies, like I know for sure that like Amazon and Google, they have their own internal log search applications. I'm sure Microsoft would also have their own internal solution because they are also huge. But when we talk about other companies which are at a smaller level compared to Google's and Amazon's, then usually as they go for ready-made solutions, because now the all the clouds like AWS, Google Cloud, they provide some fairly smart and scalable solutions out of the box. So it doesn't make sense that you implement your own ELKs. And to be honest, even this question is also not very common during interviews. In my experience, I've never been asked this question either in my mocks or in any of my actual interviews. And I've given more than 60, 70 system design interviews. But there are some concepts which are really good, and you would actually see that the solution is not that complicated if you understand the fundamentals. So it also shows, it also validates that if your fundamentals are good, your fundamentals are in place, then you can design any kind of abstract system during your system design interview. Right. Okay, so we do have some kind of fair understanding of this log search application. Okay. Yeah, so let's look at the functional requirements. So it says that each service is emitting logs with log level warn, info, error, etc. Then is emitting sensitive information like password, authentication tokens, bank details aren't being published in logs. Then there is a company level JSON format for structured logs. So it can happen that multiple microservices are emitting their logs. And when we talk about multiple microservices, we know that they are usually handled by different kind of teams. So it could be that the company is not following a universal logging format, right? So it becomes very essential that the raw log lines, they are converted into a standard JSON format, and that JSON format is understandable by our log search application. Okay. So this JSON format, uh, we all know the what's a JSON format, right? So the JSON format, if we think logically, it should have a originating host that from which server this log message came, what was the timestamp, what was the actual log message, what was the level, what was the type, what was the environment, because the logs could be coming from the production, from staging, from beta environment. Then we need to have a trace ID as well. So what is a trace ID? So this is a very interesting concept. I'm sure many of you would already be knowing it. So um, maybe let's take example of Amazon, and let's look at the user journey. So let's say the user logs in, right? Then user does browsing of products. Then user says that, okay, I like this product, so I will add it to my cart. Then user does checkout. Then user does payment. Once the payment has been validated, this information will go to some delivery and shipping. Right? User will get some notification. Right? So there are like endless use case possibilities, but these are the, let's say these are the major ones. Right? And each of this is done by a respective microservice. So this login information, this could be done by some kind of account service. This browsing, it could be done by some kind of product service. Add to cart could be the cart service. This is your checkout service. This is your payment service. This is your shipping service. This is your notification service, right? So all these are different services. Now let's say the user says that I ordered some product, right? I ordered a mobile phone and I have not received it. So this query comes to the customer service team. Now to debug this scenario, you have to go through the logs of each and every service because the user has not got mobile phone. That means you have to check that what happened at the checkout layer. Was the checkout successful? Was the payment successful, or it was later on reversed due to any reason? Was there any problem at the shipping layer? Right. So there are multiple possibilities that what could have gone wrong at any of the layers. Right. Now these all are different microservices. Right. All of these are different microservices, and so how do I search through those? So there should be a common thread somewhere which helps me to go through all of these logs. So that's where this trace ID kind of thing comes into the picture. Now, what if the time from when the user comes onto the system and does all these operations? What if at the start of the journey itself, there was some trace ID, and that trace ID was logged by each and every service? So once I get hold of a trace ID, I can see the complete journey of the user during that interaction, that particular interaction. right? So this is what trace ID is, right? So it allows us to follow a request life cycle when that request travels through multiple service servers in a distributed system. And this unique ID could be a UUID, which guarantees uniqueness across machines. Right? And there could be some other fields in the JSON format as well. Yeah, Natasha, you can give it any name, right? Trace ID, request ID. You can simply call it UUID also. Okay, what is a log type? So, okay, so log type could be um, so what many services do is that they separate out the log files. So what they could be doing is that they could have a different log file for the errors. They could be having a different log file for all the application level chatter. Mm. Then even even the this log search can have logs coming from the database also, right? So let's say this order service is a microservice, right? So that means it will have its own database also, right? Now something weird happened, some bug came. So I would be interested that at that time when this bug happened, what my application was doing and what my database was doing, right? How they correlate with each other so that I can zero in on the problem. So that means the DB logs would also be coming in this log search application. So that could be the another type of the log. Okay, hope that answers your question. Good question, thank you. Okay. Yeah, so these are the functional requirements. Now let's see at some other requirements also. The thousands of servers are generating log lines. We should have ability to search across logs, live tailing. Right? We will expect near real time latencies, at least for the recent logs. Right? The query format. So we will look at the actual query in the next slides. Right? But I already explained that how a query would look like, right? Here, that we can have user can say this should be the service name, these should be the timestamps, right, etc. The search results should be displayed in reverse chronological order so that the recent ones are shown above. Log data typically has a stable yet steadily growing scale. Right? So it happens that sometimes the log writer, the services which are emitting the logs, they can have some occasional burst also. So we have to handle that kind of scenario as well. Then this is the latency part, which I was mentioning, that the recent logs, they should have very less latency, because as a software developer, I'm very interested in last 2 hours or 3 hours of logs compared to 2 days or 3 days ago's logs, or maybe 1 month ago logs. Right? And maybe we can have some retention also, like 1 year for the logs. This is not completely true, however, because there are many compliance norms in many countries which says that the transaction related logs should be available in the system for many years. So so usually those old logs, like 1 year old, 2 year old, they are just uh, compressed and zipped and put into some kind of cloud storage where where they can be accessed at some point of time if some kind of audit company or some kind of investigation agency comes knocking at your door. Non-functional requirements. Okay. So the first one is that our system is reliable so that the logs are not lost. Of course, it should be highly available. There should be some kind of retention. Okay. Then we can say that the consistency is not paramount. So, so when I say this, let's look at the finer text also. Right? So we are saying that consistency is not paramount at real time. Right? So if there is a lag of few seconds, and this is the worst case. So maybe after 300 milliseconds or 400 milliseconds, maybe I'm not getting logs from everywhere. But I would expect that maybe after 2 seconds or 3 seconds or 4 seconds, I should be getting logs from consistent logs from everywhere. Right. So that's why we are saying the consistency is not paramount. So that this gives us some wiggle room so that we can play with our choice of database. So this makes our system AP, and let's say latency should be low for viewing logs, and let's say for last 8 hours. Right. So if I want to look at the logs from the last 8 hours, I should have a low latency. Okay. So let's look at some capacity estimation. Let's say we are designing this for a very huge company where 100,000 engineers are there. Each engineer is making 10,000 queries per day. So that means will have what 1 billion queries per day. And you can see that these are quite huge numbers, quite liberal numbers. Then assuming 100,000 seconds per day, it comes to 10,000 queries per second. So our system should be able to handle 10,000 queries per second. Then you can it just crossed my mind. So you can look at this 10,000 queries per second from another dimension also. Because what we are doing is that we are dividing it uniformly throughout the day, right? We are just dividing it by 24 hours. Let's say our company's office is only in USA, right? So that means everyone is working mostly through 8 hours window, right? So in that case, we can look at the we can have another consideration that maybe this 10,000 query per second is actually 30,000 queries per second. Because if all the 100,000 engineers are working through that 8 hours window only. So this is an interesting observation which you can mention during your interview. So now how many servers are needed to serve this queries per second? So if we say that one commodity server has 250, can handle 250 requests per second, right? And our server should be running at 40% CPU capacity. So that comes out to be 100 servers needed. Now similar calculation for the storage as well. So if we have this 1 year of retention period, and let's say we are emitting like a huge number of log lines, right? So let's say these are 400 billion log lines every day. Then we can assume that each log line has 10 terms, 10 words. And each word has 6 characters. So that will give us 24 terabytes per year. Now you can assume any kind of number that comes to your mind. So in my mind, like I just came with 10 terms. You can say 20, you can say 25, you can say that each word has 6 to 7 characters. So generally this is the average. So even if you go, even if you assume some other number also, that's fine. You just need to go through these calculations very fast in your interview, and you should be some kind of ballpark number. Okay. In my previous classes, I mentioned this is one correction from my side. So in my previous classes, I mentioned that one commodity server is 100 terabyte. So I was looking at the server sizes for AWS and Google Cloud. So usually the 100 terabyte machines are very, very, very huge. So they are very specialized machines. So generally, for the normal kind of machines which are used generally, this disk size was generally from 2 terabyte to 10 terabyte. So for the ease of calculation, I took this number as 10 terabytes. So this is one correction from my side.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today